Welcome, folks, to Unit 7. This is a brief introduction. Trigonometry is important. You're now in the second unit. I wish you well. Try to connect these ideas. It will help you to be able to learn it. If you're taking calculus, trig is essential to being successful. Okay, let's get right to it. Of course, you got your outline. All right, lesson 1. We're talking about graphing the trig functions. Don't forget the sine and the cosine are the basics. Again, references to your textbook. You got a quiz. Here is where we talk about inverse trig functions. Very important idea. Identities. I got a video about that. Again, more textbook information. So here you have your Unit 7 discussion. Please be mindful that I put several videos in there that should help you. And then you have exam 3. So be mindful of getting ready for exam 3 by doing well on 7.1 and 7.2. Let's see, what else do I need to talk to you about? I do need to mention to you that in the exam 3, I am going to put a formula sheet up for you, so be mindful of that. You could get that downloaded to your window, or you could just see it in the heading if you want to as well, so please be mindful of that. All right, let's take a moment and talk briefly about some of the concepts. Okay, when we talk about the graphs, we're really talking about three essential graphs, right? So sine, remember sine starts at 0, then at 90 it goes to 1, 180 goes to 0, 270 goes to -1, then it goes back. So this graph, okay, is y equals sine x. Know everything about that graph, okay? Again, 1, -1. That's the basics of that. Now let's talk about cosine. Let's talk about cosine. Cosine starts at the top at degree 0. It starts at 1. It goes down to 0 at 90. Goes to -1 at 180 or pi. Goes back up to 0, 270. And then at 360 or 2 pi, it goes back to 1. So that's a cycle. Now be mindful that the graph of y equals cosine of x is just the sine graph moved it's translated, right, to the horizontal shift, 90 degrees. That may help you. And then in the tangent function, be mindful that the tangent function has a period of pi. So this is pi over 2, and this is negative pi over 2. And the tangent function goes like this. Okay. Now, there are vertical asymptotes here, and there's vertical asymptotes here. So this is the graph of y is equal to tangent of x. Now, these are the 3 basic graphs that you need to know. So be mindful of that as well. Now, someone's going to say, Mr. Staples, I'm not exactly too sure how to transform the sinusoids like y equals sine of x. Well, good question. So now this is called the amplitude. This is called the phase shift or horizontal shift. This is the vertical shift. Horizontal, vertical, amplitude. And B is a special value, and I'm just going to say 360 over B is the period or the length of one wave. So how does this work? Well, I could take the graph and I could flip it over the y-axis. Okay, that would be with a little minus sign there in the front. I could take the graph and I could move it up 2 and down 2. That would be changing the amplitude by putting a 2 in for A. What else could I do? I could move the graph up. I could move the graph up. This is a midline right here, okay? So if I move the graph up 3, it would look like this. So that would be a 3. Now what would that function look like? It would look like y is equal to sine of x plus 3, okay? What else? This is a part with this b that gets people. So I'm just going to say y equals sine of 2x. Okay, and then I'm going to say y is equal to sine of 4x. Now, briefly, how can I explain that? Well, this is saying this number is how many waves are in 360. Or if you want to say 360 over b, which is 2, is 180. 180 is the length or the period of one wave. So if I was going to graph this with that's 180 and that's 360, this graph would look like this. There's one wave in 180 or two waves in 360. Now, how would I do this guy over here? I'm going to use radians in this one right here. 4 waves are in 2 pi. Someone says, can you say that another way? 2 pi over b is the period. So 2 pi over 4 is equal to the period. So the length of one wave is equal to pi over 2. All right, now remember, this is 2 pi. I don't want to belabor that pi. Okay, here's pi over 2, pi over 2. So 4 waves are in, here's, 1 and -1. So here's 1 wave, here's 2 waves, here's 3 waves, here's 4 waves. You can use your graphing calculator to help you with that, and that maybe is a good idea. So please be mindful. Also, please be mindful that sometimes you got to factor that b out. This is explained very, very well in the reading, so please take time to read that. All right, what else? Another thing that seems to get people is the idea of the inverse trig functions. Inverse trig functions. Let me just explain that. Just take a moment ever so briefly. Let's just do inverse sine. Inverse sine is this guy, okay? Also called arc sine. Now, to understand that, remember that the sine curve went like this, but I'm going to just use the 4th quadrant up to the 1st quadrant, and so I'm going to have this part of the sine curve, but it's going to be flipped. So it's going to look like this. All right, so this is 1, and this is -1. This is pi over 2, and this is -pi over 2. Okay, so notice the domain of inverse sine is -1 to 1. The range is pi over 2 to -pi over 2. Now, how about the cosine? Well, now remember, the cosine curve goes like this, correct? Okay. Now, I can get all of the possible values, but just highlighting this part of the curve, which goes from 0 to pi. So it's going to look like this. 0, right at 0, it's 1, so it's going to go like this. Okay, so this is 1, this is -1. That point right there is 0 degrees, and this is 180 or pi. All right, let's see. So be mindful that when you're talking about the domain of inverse sine, watch, the domain of inverse sine, it only goes from the value of 1 to the value of -1, and you only use the angles, that's 0, right? And you only use the angles in quadrant 1 and quadrant 4. Cosine's a little different. Without a long explanation, inverse cosine, remember its values are from 1 to -1, and the angle measures go from 0 degrees all the way over to 180. Someone says, can you give an example? How about a very, very quick one? What is inverse cosine of let's see, 1/2. 1/2, let's do 1/2. Well, where is the cosine 1/2 at? it's only 1/2 here at 60. So that's going to be 60 degrees or pi over 3. Let me do one more. Inverse cosine of negative 1/2. Well, remember, cosine's negative 1/2 here and here according to the unit circle, but inverse cosine's only defined for quadrant 2 and 1. So your only angle that you could select as an answer is 2 pi over 3. 2 pi over 3, okay, or 120 degrees. Now, if what I said seems so confusing, you just need to go back and make sure that you learn properly the general basic ideas. And watch my little video I'm going to make on like example problems, and maybe that'll help you. I do wish you the best on unit number 7. Be sure to do whatever you need to learn the material. Thanks.